this question, we want to look at if we're given the PMF of a discrete random variable, then how can we find the PMF of its function? In this case, we're given the PMF of x, and you want to find the PMF of a non-linear function of it, in this case, y is x squared. So what you're given is the PMF of x. Let's just write it down here. So we're told the values that x can take are -1, 0, and 1. And the probability that x is equal to x is 1 by 3, right? So it's the same probability for each value of x. So this is the PMF of x. Now the asking us to find the PMF of y is x squared, right? Y is a nonlinear function of x. We know when you want to find the PMF, we need to see, the PMF essentially shows us all the values the discrete random variable can take along with the associated probabilities. So let's first see what are the values y can take. That's the first thing we need to note. What are the values it can take, and then we'll find the associated probabilities. What are the values? Because for PMF, you need the values and the associated probability. So let's start with the values. What are the values y can take? So let's see. Now, when x, let's see for each value of x, what value y do we get? When x is -1, so y is -1 whole square is equal to 1. When x is 0, y is 0 square is equal to 0. When x is 1, y is 1 square is 1. So there are only two values that y can take, right? So possible values for y. So the possible values y can take 0 and 1, right? So these are the only two values that y can take. Now let's find their associated probabilities, right? For associated probabilities, right? Because for PMF, we need both values and that. We first looked at, given each value of x, what's the value y, and from there we saw what are the unique possible values y can take. The only two possible values, 1 and 0. Now for associated probabilities, now let's start with the probability y is 0. Now the probability y is 0. Now when is y 0? Y is only 0 when x is 0, right? So the probability y is 0 is essentially the probability x is 0, because y is 0 when x is 0, right? So basically we can see if y is 0 when x is 0, right? So the probability that y is 0 is essentially the probability x is 0, because y is a function of x. So we need to see, to find the probability of y, we need to see what value of x does it correspond to. And the probability x is 0 is just 1 by 3, right? Now, what is the probability y is 1? Now, y is 1 when x is either -1 or x is 1. So probability y is 1. So it's not, y is 1 doesn't correspond to one value of x, it corresponds to two values of x. Probability y is 1. Now, y is 1 when either x is -1 or x is 1, right? Let's look at this, right? So y is 1 when x is -1, y is 1 when x is 1, right? So the probability y is 1 corresponds to two values of x. And we know whenever we want to find the probability of a discrete random variable using its PMF, we just sum up the PMF over those values of the discrete random variable. So if I want to find the probability x is -1 or the probability x is 1, so I'll just sum up the PMF of x over these values, right? So this would just be probability x is -1 plus probability x is 1, but let's try to understand the logic behind it. Okay, why does the addition work? We know OR means union. So I can write this as probability x is -1 union x is 1. Now, x is -1 and x is 1 are mutually exclusive events, because when you perform a random experiment, you get exactly one outcome. So you get only one value corresponding to the random variable. You can't have x taking both values. When you perform the random experiment, you only get one value, the random variable. So since they're mutually exclusive events, the sum, the union of mutually exclusive events is the sum of the individual probability. So this is why the addition part works, right? We know this is how it would have been found, but we're just trying to look at the logic behind it. Since mutually exclusive. Right, so we know what probability x is -1 or x is 1. We can just find it by summing up the PMF of these values of x, which is probability x is -1 plus probability x is 1. So we just looked at in these two steps what's the logic behind it. Since mutually exclusive, right? And then we know the probability x is -1 is 1 by 3, and so is the probability x is 1. So this is 2 by 3. So we have found the PMF of y. Let's just write it over here in a similar way we wrote x. Is y can take two values 0 and 1. And the probability y is y. We found this to be 1 by 3 and we found this to be 2 by 3. we can check our PMF by seeing does it sum to 1, because we know PMF always sums up to 1. Some of the all the probabilities in the PMF has to be 1, by seeing does it sum to 1. In this case, that means we know 1 by 3 plus 2 by 3 is 3 by 3, which is equal to 1, right? So we'll just check whether our PMF sums up to 1. I is the sum of all the probabilities in the PMF 1. So in this way, we can find the PMF of a of a function of a discrete random variable. It was a non-linear function, right? We could do similarly for linear function as well, right? So the simple thing is you first look at what possible values can it take, and then you just find the associated probability. Sometimes one value y may just correspond to one value of x, of which it is a function of. Sometimes one value y may correspond to multiple values of x as well. Like here we saw y is equal to 0 corresponds to x is equal to 0 only, but y is 1 corresponds to x is minus 1 and x is 1. So when you're finding the probabilities, you have to take that into account.